thanks for your focus, scholars. So today we're going to continue talking about covalent bonding. And we won't really ever get away from covalent bonding throughout the rest of the term because it's just super important. And so we're going to really focus intently on covalent bonding all the way through our bread unit and probably through our fermentation unit as well. And then we'll start to take a look at some other concepts like reactions and thermodynamics and acid-base chemistry. What I want you to focus on now is this word that we've seen for a while, right? Element or elements. And we think about elements as these like symbols that we see on the periodic table, but we can also think of elements as chemicals, okay? And so elements are chemicals, metallic or molecular, that consist of only one type of atom. That's what makes an elemental chemical, okay? So some examples of chemical elements are oxygen gas, O2, or actually ozone gas, O3. So when you've got two different chemical formulas for the same element, okay, O2 versus O3, you call those guys allotropes of each other, okay? So like I'll just put that word down because why not? Those are allotropes of each other, okay? Allotropes of elemental oxygen, right? But there's also N2, nitrogen gas, and we've got carbon, right? But I'll put a little S next to it so that you know that I'm talking about solid carbon, which has two forms, okay? Graphite, which is your pencil lead. Does anybody know the other form of solid carbon? Get ready for your mind to just diamond, okay? The same chemical that makes up your pencil lead makes up diamonds, like straight up diamonds. Hardest substance on the planet, diamond, made up by just carbon atoms. That's it, just pure carbon. But they're arranged differently at the molecular scale, so we'll probably talk about that at some point. What else is elemental? Like sodium, right? Like sodium solid, so sodium metal, or like aluminum solid, that's aluminum metal, okay, that's in your laptop, right? Your laptop is made out of aluminum, right? So those things are just all one type of atom. And in all fairness, the aluminum in your laptop might be, welcome to RC, might be an alloy, but I would actually, it's probably pure aluminum, or very close to, because I've machined pure aluminum and it looks just like that. So we'll say that's almost entirely aluminum, if not just pure aluminum. Okay, so that's what elements are. We also have compounds. So compounds are chemicals that consist, if someone wants to turn that off, that'd be great, of more than one type of atom. Okay, so if you know like that's your cell phone, like no shame, like you can just like no judgment, you can just hop up and like turn that thing to silent or whatever. Thank you. Okay, so more than one type of atom. And so here are some examples. So CO2, right? H2O, carbon monoxide. Let's just talk about all these chemicals. So carbon dioxide is the stuff that we breathe out. Okay, so we breathe in oxygen, we breathe out CO2. Water, we've talked about a lot. That's very, very important in so many different ways on planet Earth. Carbon monoxide is interesting. So like carbon monoxide is very interesting because like at your house right now, like raise your hand if you've got a gas grill or a gas stove or a gas oven at your house, right? You like go to the stove and you turn it on and there's an actual flame there. Okay, so then you by law have to have a carbon monoxide detector in your home. Okay, most homes actually have them, even homes that don't have gas lines, but you definitely have to have one of those because you could wind up in a situation in which your house gets full of carbon monoxide. It turns out that carbon monoxide sticks to the hemoglobin inside of your blood even better than oxygen does. So if your blood and your hemoglobin are saturated with carbon monoxide, what can't bind? The oxygen, right? And so what's crazy is your face looks really, really red, but you're actually poisoned by carbon monoxide. that stuff is like sticking so tightly to the hemoglobin turns red, right? And like you can actually die from, it's actually a form of suffocation, right? Oxygen deprivation. So you can be poisoned by that thing, right? That's carbon monoxide, okay? That's also like why you always want to make sure that like your garage door is up if you're running your car inside of your garage for whatever reason, okay? This stuff comes out the tailpipe of a car at a certain concentration. Okay, so enough about compounds versus elements, right? Almost, right? We forgot about our ionic compounds. So like NaCl or magnesium oxide, or let's say calcium fluoride, okay? Calcium fluoride, that's also an ionic compound. So molecular compounds, ionic compounds. Okay, there are also metal alloys, like steel is an alloy, so those are a little different. We don't normally think of those as compounds, so we'll table that for probably AP Chem. Okay, so next order of business. So what I wanted to talk about today is I wanted to talk about familiar organic compounds. Okay, and what's crazy is that these organic compounds are familiar without actually being so like obvious or recognizable to us. Like I'm going to put a bunch of names on the board for these different compounds, and you're going to be like, I've never heard of that in my life, and then I'm going to explain to you what it is, right? And you're going to be like, oh dang, that's been in my life for a long time, and I didn't even know. Because like that's just the way chemistry is. It exists all around us and in us, and we don't know unless we study it. So okay, so familiar organic compounds. So the first thing we're going to talk about, or the thing we're really going to focus on today, are alkanes. Okay, so I'll put that definition up in a second, but before I do, I actually want to talk about where this word organic comes from. So organic compounds were discovered from products of living organisms. Okay? Right? Organic from living organisms. So like the early chemists who studied this stuff thought that organic chemicals could only be made by life, okay, by living organisms. So there was this concept that like only living organisms could make these things. But that turns out to be false. Remember that things like this plastic chair are made up of organic polymers, right? And then you've got like a plastic water bottle, same thing. And this synthetic fabric, this in my lunchbox here, that's also made of organic polymers. So humans can do many different things with organic chemicals to make organic chemicals, other organic chemicals that are unnatural. But even to this day, most organic things, like I would imagine, I don't know for sure, but it'd be hard for me to believe that otherwise, like this synthetic fabric here and like this polymer over here, which you wouldn't find either of those in nature. Those come ultimately from something that was found in nature. So like what'll happen is crude oil will get distilled and fractionated. That means separated into different chemicals, and then those chemicals can ultimately be used as what's called a feedstock or a starting point for making like things like these other polymeric things that we have. This bad boy right here, paper, right? That's a natural polymer. Cellulose, that's made from trees. Okay. So the simplest organic compounds are called alkanes, but they're super important. And you're never going to understand organic chemistry if you don't understand alkanes. Like you got to know about these guys. So alkanes are compounds, and they're organic compounds. I'll put organic in parentheses. That consist only of carbon, hydrogen, and single bonds. okay? And one thing that I should add up here, these organic compounds were discovered from products of living organisms. And these guys, these organic compounds, these guys over here, like, I'll double underline that thing. These guys contain carbon. Okay? Carbon is that common thread. We ended on a cliffhanger last time. We asked ourselves, like, how carbon chemistry works. We're going to start to see that today. Okay? And so these are all carbon-containing compounds. And there are certain chemicals, like carbon dioxide and carbon monoxide, that we actually consider inorganic because they don't come from, like, they don't have to come from life forms. No, they don't. But generally speaking, when something contains carbon, we think of it as an organic chemical, okay? And so alkanes are the simplest organic chemicals, and they consist only of carbon, hydrogen, and single bonds. Okay, so what are some of these alkanes, and why do we care at all? So I'm going to show you formula, name, structure, which is huge, and then relevance. The structures are going to start to get big. So the first one has a formula of CH4, and it's called methane. And its chemical structure looks like this: C, H, 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 H. And so if you write it on the board like that, it looks flat. You'd easily be forgiven for thinking that methane was like a flat molecule. Methane's not a flat molecule. Methane's not flat at all. It actually has a shape that we call tetrahedral, and it looks like this. So this is one carbon atom in the middle with like four of these hydrogen atoms bonded to it, right? This is methane. And so if you look at it from just the right perspective, yeah, sure, it looks like that, right? But it's actually tetrahedral, okay? And I'm not going to represent three-dimensional structure on the board because we're going to build a lot of these things. But I'll pass this little methane molecule around. I'll put it up here in front of the camera, right? So there's your methane right there, okay, tetrahedral. So I'll pass this guy around so that everybody can actually like get to feel, hold, touch that methane, because that's how we learn more about chemistry. When we engage our tactile sense, we learn more than we do if we just engage our visual sense, okay? And here's the relevance of methane. So, raise your hand again if you've got a gas stove at home. Okay, so methane is in fact natural gas. Okay, so when you hear the term natural gas in like the news or when you see it in print, that's what we're talking about, okay? This business of fracking, that's a methodology for obtaining natural gas, okay? That's what fracking does. And natural gas is only one aspect of methane's function. So yeah, it serves as a heat source for us, a fuel source, but what it also serves as is a greenhouse gas. So guys, what is the relationship between greenhouse gases and global warming? Greenhouse gases increase or decrease global warming? So on the count of three, greenhouse gases, 1, 2, 3, increase global warming, right? They make the earth hotter, okay? So that's exactly what methane does, okay? Methane actually makes the world around us hotter, and a lot of that methane that winds up in the atmosphere is from animal agriculture. So when our cows and our pigs and our chickens produce waste, that waste is full of bacteria that are what is known as methanogenic. So they generate methane, and that methane just escapes into the atmosphere and warms our planet. So animal agriculture has many detrimental effects on our society. Producing methane is one of them, okay? So, okay, I'm going to skip from methane to a slightly bigger compound because that's the compound that's familiar to us, and it's C3H8. And you'll recognize this name right away, propane. Okay? Propane. And so I want you to think really quickly about where you've heard that before, because I'd love for somebody to be able to like chime in and tell us what propane is and where it comes from. Okay, so propane. Where does propane come from, scholars, my scholars? Propane. Propane? We don't know? Say, what'd you say, Cassandra? What now? Gasoline, no. Propane's not gasoline. Yeah. Okay. So, I was just double checking on fracking. Fracking produces not only natural gas, but you can also use hydraulic fracturing to drill for or to harvest oil. Okay. So crude oil. Okay. So propane, really close. It's not